Okay, chapter 6D looks at modular transformations. It's just what happens when you take, the first thing is what happens when you, take a function and you take the absolute value of it, or the next thing that the unit wants to know is what happens when you take a function but you take the absolute value of all the x values. It's very basic. You can see what it is in your graphing calculator. First of all, let's start with the absolute value. So we know the absolute value graph looks like this. It's a line. It seems like a line, but we know it's kind of like a piecewise function. You know, it's x when x is greater than or equal to 0, but it's negative x when x is less than 0, which means we negate all the negatives. So it's kind of like what it is, and you might say, oh, you know what, it looks like you took the negative part and you flipped it over the x-axis. Well, that's exactly what's going on. That's what's going on. So to graph y equals the absolute value of f of x, first I would recommend graphing the original graph f of x. And then for all the parts where the function is underneath is negative, you'd reflect it over the x-axis. So for all f of x less than 0, reflect over the x-axis. So let's take an example. For example, y equals the absolute value of 2x plus 3. So step one, we just graph the line. Let's just graph the line here. Now, we know what this looks like because it's increasing, and the y-intercept is 3. And so this is 3, and this is negative 1/2, 1.5. And the idea is for the absolute value, what we're going to do is we're going to take the negative part and reflect it over the x-axis. So it's still positive, but then it reflects it. Things you want to, and so once again, so this is the absolute value. Now here's the interesting thing about the absolute value function. The original function was 2x plus 3, so this right branch is still y equals 2x plus 3. But the question is, what is this left branch? Well, technically, this left branch is y equals negative 2x plus 3. We're going to hold on to that for a second. Let's try another one, this time with a parabola. How about we use the parabola? Let's use the parabola. Y equals, so let's say it like this. F of x equals x squared plus 3x minus 10. And they'll say graph the absolute value of f of x. No problem, because you're experts, right? How are we doing for time? So let's graph this then. So we're going to graph it. Right? Here's my x and my y. I know that if I factor this, I have, it's x, let's see, plus 5 minus 2 equals 0. So x equals negative 5 is a 0. And x equals 2 is a 0. I know that negative 10 is my y-intercept. I also know that the average of my roots is my axis of symmetry. My axis of symmetry is x equals negative 5 plus 2 over 2. That is negative 3, so this is negative 1.5. So this is the axis of symmetry. And it's something down here, negative 1.5. You can use your calculator. So what is it? It's a 2.2. So it's a 2.25. Negative 4.5. So we have negative 2.25 and then minus 10. So it's negative 12.25. So that's, what is that point? That is negative 1.5, negative 12.25. This is negative 10. And good, so let's take a look at our original graph. It looks like this. Nice. Now the question is, how do we graph the absolute value function? Well, how do we graph the absolute value function? Well, it's very straightforward. First, we graphed our original parabola. Second, wherever it's negative, you're going to reflect it over the y-axis, which means that negative 1.5, negative 12 becomes negative 1.5, 12.25, and negative 10 becomes positive 10. And so we have the graph that looks like this. Positive, 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 positive. Negative becomes reflected. And then the positive stays the same. Once again, if you think about it, these two branches here are still f of x. This is f of x, but this reflected curve is actually negative f of x. As I said before, we're going to use that to help us solve problems. I'll be back with another video.